Good morning, dear children. Welcome back to your video lesson. We started revision for the chapter Language of Chemistry, chapter 5 in our textbook. Previous video lesson was revision 1. I'm Mrs. Roshni Nair. Today we will start revision 2 for the chapter Language of Chemistry. So before we start today's topic, let us just revise the term chemical reaction. Chemical reaction is defined as a process in which one or more substances called the reactants are transformed into one or more different substances called the products. And we understood this concept by understanding the example here. If two molecules of hydrogen reacts with two molecules of oxygen, both hydrogen and oxygen will be reactant and the result formed will be H2O or water molecule. That will be the product. So reactant is hydrogen and oxygen. Product is H2O or water. Now let us understand chemical reaction. What does it involve? A chemical reaction involves the breaking of existing bonds between atoms or groups of atoms of the reactants. Atoms can be from the same reactant or it can be between the groups of atoms of different reactants. And chemical reaction also involves formation of new bonds which forms new substances which are termed as products. So definition of reactant and products both are important to understand. In my previous video lesson, we started understanding the characteristics of occurrence of any chemical reaction. Under the characteristic, we studied that whenever a chemical reaction takes place, the matter changes into a new substance. Under that, we also studied few characteristics, that is, whenever a new substance is formed, the main characteristics can be either change of color, change of state, change of smell. Same when the chemical reaction takes place, there will be certain external indications, or we can say there will be certain characteristics which shows that a chemical reaction has taken place and also a product is formed. Under these external indications, today we will study about characteristic change, that is, when the product is formed, there will be evolution of gas. And we will study the product, there will be formation of precipitate. Precipitate is nothing but an insoluble solid substance. And we will also study heat evolved or heat released whenever the reactants give rise to a product. So as I mentioned, we will start with characteristics of occurrence of a chemical reaction. Under that, we will start the first heading, that is characteristic change or evolution of gas. Right? Evolution of gas whenever there is a addition of reactants to form a product. Now, how many of you had seen these type of antacids? When we put these type of antacids into the glass filled with water, you can see this type of reactions. It can be with anything, even any antacids or vitamin C tablets and all. We can see these types of bubbles coming out of that particular tablet when you put it in a glass of water, right? Now this reaction which forms a product, there we are going to study about these type of evolution of gases, right? In daily life also we had seen these type of examples. So when we are understanding evolution of gases, there is one particular term which has much importance, that is effervescence. Effervescence, very important word. What is the meaning of effervescence? It is the formation of gas bubbles in a liquid during a chemical reaction. Formation of gas bubbles. Same, I told you, no, for our daily experience, we had seen antacids. When you put it in water, we had seen the bubbles coming out of from that particular tablet. So there, this formation of gas bubbles in that liquid, that is in this case water, when the chemical reaction is taking place, that gas bubbles formation is named as effervescence. Again, let me repeat, it is an important term in examination point of view. So definition is very important. Effervescence, formation of gas bubbles in liquid. Now let us come to the examples for this. Whenever many chemical reactions are taking place, there will be some amount of gas which is seen to be evolved as one part of the product. Gas is evolved and also product is formed. Now let us see a small example. It is stated as activity 6 in our textbook, page number 60. Here in this activity they have stated reaction of iron with dilute sulfuric acid. When iron reacts with dilute sulfuric acid, in the product there is a evolution of hydrogen gas, that is effervescence is clearly visible. Definition of effervescence, let me repeat once again, like the previous slide, it is important. Now coming to the reactant, can you see on the screen? That is iron Fe. Now in the test tube, when you're doing it in a chemical laboratory, we can say it is normal iron. It can be in the form of nails or maybe it can be in the form of granules. So iron in the test tube when you take and add it with H2SO4 is dilute sulfuric acid. When this iron fillings that reacts with dilute sulfuric acid, what you can see first is hydrogen gas which is evolved. So it is evolved like bubbles, right, as it is shown in the picture. So bubbles, you can see first thing hydrogen gas. Now it is like a displacement reaction. From H2SO4 hydrogen is displaced. It is seen as bubbles and SO4 which is remaining will react with iron Fe. So the resultant product will be FeSO4. What is FeSO4? Iron sulfate. Fe iron SO4 sulfate. Iron sulfate plus hydrogen which is evolved as gas is formed. So if you want to write a statement, what you write? When iron reacts with dilute sulfuric acid, H2SO4 is sulfuric acid, and in this case we are using dilute sulfuric acid. So iron Fe, when it reacts with dilute sulfuric acid, iron sulfate with the evolution of hydrogen gas is formed. When you're writing the equation, how you write? Iron, that is Fe, which is solid in form, reacts with H2SO4, which is dilute in nature, aqueous solution. AQ in this chemical reaction denotes for the aqueous solution, right? So H2SO4 aqueous gives, what is the final product we are getting? Fe, iron reacts with SO4, again, which is aqueous in nature, watery in nature, aqueous. FeSO4 means what? N sulfate plus H2 or hydrogen, and what we had written in bracket, G or gas. You remember how we used to show with arrows? Arrow pointing upwards will be gas. So hydrogen gases evolved. Let us understand few more examples for evolution of gas according to our textbook. It is mentioned, that is laboratory preparation of gases from substances applying the relevant condition. Laboratory preparation for us to understand, right? So here in this example, we are going to learn what are the few gases evolved: oxygen, hydrogen, hydrogen chloride, carbon dioxide, and also sulfur dioxide. Around 5 gases you can see. These are the gases which are evolved during different chemical reactions. Now let us see the first one. First one, K is potassium, Cl is chlorine, O is oxygen. So what is the first reaction? When you heat potassium chlorate, KClO3, potassium chlorate, when you heat. Here you can see this delta. Let me circle. Can you see here one small delta sign? So this delta means when you are heating that particular reactant. So potassium chlorate when you heat, and there is a catalyst which is involved. Catalysts are substances which are used either to increase the speed of chemical reaction or to decrease the speed of that particular chemical reactions. End of this video lesson, I'll show you a small video from our very own Tata Classage. There they had explained catalyst better. So you can understand catalysts are the substances which they participate in the reaction. They will only add, either they will increase the speed or they will decrease the speed, but the product will not have this catalyst in any way. These are just added to change the speed of the reaction, right? So we were studying when we heat potassium chloride, delta sign indicates heat. And when manganese dioxide is used as a catalyst, what is the product we are getting? KCl, that is potassium, chlorine and oxygen, O2 gases evolved. That is why it is written under the column gas evolved we have oxygen. Next chemical reaction, when zinc reacts with hydrochloric acid. Hydrochloric acid HCl. Zinc is Zn. So when Zn, zinc reacts with dilute hydrochloric acid HCl, what is the product formed? ZnCl2, zinc chloride, and what is the gas evolved here? H. From HCl, hydrogen gas is evolved and Cl reacts with Zn. Third one, when sodium chloride, that is our common salt HCl, when it is added to concentrated sulfuric acid H2SO4, And what is the degree of heat mentioned there? Can you see? That is more than 200 degrees centigrade. NHSO4 is formed, and also hydrogen chloride gases evolved. HCl gases evolved here in this case. I'll show you these now. First, you can see KCl when it is heated, that is potassium chloride. That reaction I had shown in the box, which shows all the apparatus assembled. And oxygen, since it is gas, it is evolved. You can see it in that tumbler because of light weight, right? It will be floating on top, right? Fourth one is calcium carbonate. When this reacts with dilute hydrochloric acid, again heat delta is mentioned. What is the product we are getting? We are getting CaCl2, calcium chloride, plus H2O, that is water, and gas evolved here is carbon dioxide. Last one is when you heat sodium sulfite, SO3 sulfite, sodium Na sulfite SO3, Na2SO3, when we heat this with dilute hydrochloric acid, what are the products we are getting? We are getting sodium chloride, NaCl, plus H2O plus sulfur dioxide in the form of gas. So gas evolved is different based on the product, right? Based on the products which are reacting, based on the reactants, the product has different gases which are evolved. So first one, potassium chloride, you can see in the picture. This is the second one, that is concentrated sulfuric acid, and sodium chloride, third one, NaCl part, this one, NaCl, you can see here, sodium chloride mentioned here, that is common salt. Sodium chloride is common salt. When it is added to concentrated sulfuric acid, again here this concentrated sulfuric acid is added so that this reactant, the product will be dried, and later on we will get dry hydrogen chloride. That gas is evolved. So this here, it will be dried. Next you can see one more, that is preparation of, one more evolution of gas for our example is preparation of sulfur dioxide. That is sulfur dioxide gas evolved. Last reaction in our textbook, when you heat sodium sulfite, Na2SO3, again it is in solid format, Na2SO3 sodium sulfite, when you heat in the presence of HCl, dilute HCl, we can say dilute hydrochloric acid. What are the products we are getting? We are getting NaCl, again in aqueous form, sodium chloride, plus H2O, liquid water, plus sulfur dioxide gas which is evolved. So in chemistry labs, when you want to prepare sulfur dioxide can be prepared by treating sodium sulfite with dilute sulfuric acid or hydrochloric acid, and this is the reaction which takes place, and sulfur dioxide gas which is produced, it passes through the gas washing bottle containing concentrated sulfuric acid. The gas is dried. As I mentioned in the previous picture also, this is the way a gas is dried, this one, right? So the gas is dried and then as a product it is collected here. It is collected by, what is this? This is a downward delivery method. So sulfur dioxide which is produced is passed through a gas washing bottle containing concentrated sulfuric acid. The gas dried, the gas is dried and it is collected by downward delivery. Previous ones when we were learning about oxygen, it was downward displacement. Why? Because the gases are very light, so they will be collected on top of the inverted. Now coming to the next type of characteristic change, that is precipitate formed. Now before understanding the examples or next activity, let us understand what is the meaning of precipitate. Precipitate is defined as insoluble solid substance. Insoluble means which will not dissolve. Insoluble solid substance formed during chemical reaction. I had kept this bracket empty because I wanted to show how it is shown in any type of chemical reaction. If you remember previous when we were showing evolution of gas, I had told that we are showing it by an arrow which points upwards. Now when precipitate, which is an insoluble solid substance, when it is formed, when we are writing a chemical reaction, we will show it in the form of arrow which points downwards. So down pointing arrow. So in certain chemical reactions, when these type of reactions takes place, there is an insoluble solid substance which is formed known as precipitate, and remember it is formed when two solutions of soluble substances react. In our textbook in page number 61 they had given few activities. In this activity 7 they had mentioned that different reactions between two solutions result in the formation of precipitate. So in this picture on the screen, you can see that when a solid substance is formed, when two solutions react, you can see a clear precipitate. Can you see this blue color precipitate formed? It is. Why it is shown with arrow pointing downwards? Because precipitate, being heavier in nature, will settle down in the test tube, right? Compared to the gases which are evolved, are lighter in nature, so they will be collected on top, right? So here the precipitate formed in any chemical reactions is shown with that arrow which points downwards. So here you can see precipitate formed, and can you see here I'm showing a test tube which has white color precipitate which is formed. And also it is not compulsory that it will be white or it will be blue in color, but depending on the type of chemical reactions, the product formed will be having different types or different color of precipitate which is formed. Different color, it can be yellow, it can be green, it can be red, it can be like this black in color, blue in color, white also. Gelatinous white is there, chalky white is there, milky white is there. So in white also we have different types of precipitates which are formed. I can name only single, like it is milky white, it is only white PPT, but white PPT also can be differentiated into different types of whites. Milky white, gelatinous white, and also chalky white, different colors. Same blue precipitate, blue PPT we say, pale blue PPT we say, right? Now let us start with the reactions which are given in our textbook, page number 61. You can refer to this page. Now, in this page, they had given different chemical reactions. That is when there is a reaction of silver nitrate and dilute hydrochloric acid. Silver nitrate is represented by AgNO3. When it reacts with hydrochloric acid, HCl, what is the product which is formed? HNO3 and AgCl. AgCl, down arrow represents it is the precipitate which is formed. And what is the color of the precipitate? It is silver chloride. AgCl will be milky white precipitate. Silver is Ag, chloride Cl. AgCl, down arrow shows it is a precipitate and it is milky white in color. So out of these reactions which is shown in the textbook, whatever it is written, the chemical reactions, I will show you this first one, milky white precipitate. I can show iron sulfate when it reacts with sodium hydroxide and NaOH. What is the product formed? Na2SO4 and also iron hydroxide, FeOH2. Hydroxide, that is why that bracket is there which shows hydroxide. Again, precipitate is dirty green PPT. I'll show you. Next one also I can show, that is reddish brown PPT when iron chloride reacts with ammonium hydroxide. What is the precipitate form? Iron hydroxide. And also I'll show one more, copper sulfate, very common one. See, I just wanted to show you different shades. I will show you one white PPT, I'll show you one green color, one brown color and one pale blue PPT. Copper, wherever copper comes, copper itself, copper sulfate itself is a bluish color salt, right? So when it reacts, what is the product which is formed? Copper hydroxide, and the precipitate will have pale blue color. Zinc sulfate and sodium hydroxide, when it reacts, again zinc hydroxide, it will be same as our white gelatinous white PPT. And last one is lead nitrate. Lead nitrate PbNO3 too, when it reacts with ammonium hydroxide NH4OH. What is the product formed? NH4NO3 and lead hydroxide. OH is hydroxide. We had seen iron hydroxide, iron 3 hydroxide, copper hydroxide, zinc hydroxide, and last one is lead hydroxide. Whenever hydroxide is formed, it will be always written in bracket. So when we are learning in next revision lesson, we will learn how to write a chemical reaction, right? There we will understand this hydroxide. Always we should write it in a bracket. Last part of the chemical equation when we are learning. So again, that lead hydroxide formed is chalky white precipitate. Let me show you now this reactions. Okay, first one was AgNO3, which is silver nitrate with liquid in nature. It reacts with dilute hydrochloric acid, again liquid. What is the product which is formed? AgCl precipitate, white precipitate is formed along with HNO3. So this is AgNO3 or silver nitrate. Silver nitrate solution, we will take it in a test tube. Sorry, silver nitrate is a solution. We will add it to this. In this test tube, we had taken dilute hydrochloric acid. First one, the bottle shows silver nitrate solution. In the test tube, we are showing dilute hydrochloric acid. So when you are taking this dilute hydrochloric acid in that test tube, and when you add few drops of silver nitrate into the test tube, you can see a white color precipitate forming, right? Let me show you clearly. Yes, this is the final silver chloride. And you remember what I had mentioned? It is milky white precipitate. Milky white precipitate which is formed. Let us understand one more example of precipitate formation. This is NaOH means what? Sodium hydroxide. Na is sodium, OH is hydroxide. Sodium hydroxide, when it reacts with Fe is iron and SO4 is sulfate. Iron sulfate. When sodium hydroxide reacts with iron sulfate, what is the final product which we are getting? We are getting FeOH twice, that is iron hydroxide. What is the color they had mentioned? Dirty green precipitate along with Na2SO4. This is FeSO4 solution or iron sulfate solution. Right? This bottle contains iron sulfate solution, and we will take dilute NaOH, dilute sodium hydroxide in the test tube. Now when we start adding iron sulfate into this dilute sodium hydroxide solution, you can see there is a color change. Can you see here on the top? There is a color change. That is, dirty green precipitate starts forming in the test tube, and it is quite clear because dilute sodium hydroxide was more or less like water, transparent also. When dirty green precipitate is formed, it is clear. This is, what is the product named as? FeOH, that is iron hydroxide, dirty green precipitate. One more I will show you, that is FeCl3 or iron chloride when it reacts with sodium hydroxide NH4OH. Ammonium, NH4 is ammonium hydroxide, I'm sorry. So it is FeCl3 is iron chloride when it reacts with ammonium hydroxide NH4OH. What is the resultant product we are getting? We are getting NH4Cl and FeOH or iron hydroxide. It is formed, and what is the color of the precipitate? It is reddish brown in color. Iron always had that brown. I'll show you that iron color is specific and different. So first let me take, this is NH4OH or ammonium hydroxide in this bottle. It reacts with FeCl3 or iron chloride, which is already purple red in color. FeCl3 solution is purple red in color. This way, can you see this? This is actual iron chloride color. So it has that purple reddish color. Now next one, when it reacts, when we add that, that is when we are adding ammonium hydroxide to this iron chloride solution in the test tube. So can you see the effect there and here in this level? See here, what is it forming? It is a reddish brown precipitate which is forming reddish brown in color. Let me show you clearly. Yes, yes, actual color. Can you see reddish brown insoluble precipitate which is formed? It is a clear view of the precipitate formed. Next one more I can show you. See, this is the actual test tube which shows the chemical reaction which has taken place. One more I will show you, precipitate formation, that is copper sulfate CuSO4 when it reacts with sodium hydroxide NaOH. What is the product formed? Na2SO4, and precipitate formed is copper hydroxide CuOH2. Copper, whenever copper comes into picture, there will be mentioning of blue color. Even in this reaction, we can make out a pale blue PPT, precipitation. Yes, copper, as I told, copper sulfate, blue in color, here crystals here. And when we add it to dilute NaOH or the sodium hydroxide solution, you can see this blue PPT which is formed, pale blue PPT. When you are adding it slowly, that is when you are adding dilute sodium hydroxide slowly, you can see the change in color, right? So actual is this one. See, I just taken a clear picture, close picture. It shows a pale blue color precipitate starts forming when you add sodium hydroxide to this copper sulfate solution. So we studied all these and I had shown you clear pictures of the precipitate formation, milky white PPT, that is silver chloride. Then second one was iron hydroxide, which had dirty green precipitate formed, dirty green in color. Reddish brown also we had seen whenever iron chloride reacts with ammonium hydroxide. And we had also understood copper sulfate when it reacts with sodium hydroxide. We will get a pale blue color precipitate. Now coming to the last characteristic change during the chemical reactions. Again, in this characteristic change, that is when we are studying the last one, it is heat evolved or heat released. In this type of chemical reactions, two important terms have to be understood. One is exothermic and one is endothermic. Exo and endo. These are two types of reactions. Let me explain. Exothermic reactions is a chemical reactions in which heat is evolved, given out. When heat is given out, released or evolved, it is known as exothermic, given out. Then another term is endo. When in any chemical reaction, heat is absorbed by the reactants, it is known as endothermic reaction. So relate, exo means evolved, endo means absorbed. Relate and understand, it will be there always in your mind. So in certain chemical reactions, there will be release in energy or it can be energy absorbed also. Hence, there are two types of chemical reactions which are seen depending on the energy change. What are the two types? Endothermic and exothermic. Exothermic we can define as a chemical reaction in which heat in the form of heat, again it is a form of energy. Heat energy is evolved, and in endothermic a chemical reaction in which heat is absorbed. Again, there are few things to be understood that whenever we are mentioning an exothermic reaction, it is represented as plus delta. In the beginning only I told plus delta, that is delta is a triangular shape which we show when we are saying that heat is any chemical reaction or the reactant when we heat, right? So delta you should write at the end of the chemical reaction. It represents as heat evolved. End, that is not in between or above the arrow, we are writing at the end of the reaction. Last, yeah, you can see in this picture where carbon, first one is the reaction of calcium oxide, CaO, it reacts with water, normal. H2O, what is the product we are getting? CaOH, calcium hydroxide, plus delta. As I told, delta or triangle should be always written at the end of the chemical reaction. So this delta in the end of the chemical reaction shows that heat is evolved during this type of chemical reaction. So whenever heat is evolved or given out or released, it is known as exothermic, right? Another example is SO2, sulfur dioxide. When it reacts with oxygen, this V2O5 and 450 degrees centigrade is heat. V2O5 is again a catalyst, we can say. And what is the product here we are getting? 2SO3, that is V2O5, which is used as a catalyst. What is the name given in the textbook? It is vanadium pentaoxide. Penta means 5. V is vanadium pentaoxide, 5 molecules of oxygen, which is used as catalyst. And heat is again released. That is why it is written under the type of reaction exothermic. Next, nitrogen, when it reacts with hydrogen, under Fe, it is 450 degree centigrades. Again, it is finally divided ion. It is used as catalyst here. What is the product formed? NH3 plus delta, exothermic reaction again. Then we have hydrogen plus oxygen, normal reaction. If you remember, we had studied this reaction here in under the heading change of state, decomposition of water. Right? There we studied hydrogen when it reacts with oxygen H2 plus O2, we get water H2O. There, same H2 plus O2, we are getting H2O and also delta, that is heat is released. There was a battery shown in the picture along with this setup of hydrogen oxygen gas which is formed in the inverter test tube, right? So here also you can see plus delta means it is an exothermic reaction. Again, one more important part of this heading, that is characteristic change in the chemical reaction where heat is evolved or released. There are few examples of these exothermic reactions in our daily life or everyday life. Important again in terms of examination point of view. They can directly ask you a question to state few examples where exothermic reaction takes place in our daily life and heat is released. Heat is released, you can directly relate to many things which is occurring around us. Maybe this is rusting of iron, right? And you can say setting of cement. Can you see cement when it is set? There will be some type of heat which is released. And also normal, that is our human body also have certain amount of heat which is released when you do any sort of work. And if you don't remember all this, best example is either burning of fuels, normal, coal burning, or this is very easy to remember, that is bursting of firecrackers. Again, these comes under our everyday life experience where a chemical reaction which takes place has certain amount of heat which is released during this type of chemical reaction. With that, we come to the end of this video lesson. Do take care of yourself, dear children, and complete the questions sent in the PDF format. So thank you and take care.